Let's do just one more. We're going to do a different type of line integral now. Remember that you can write these things many different ways. If you write the dx and the dy separately, it doesn't mean it's a different type of question. It just means that you're choosing to write like the part that's going to have the x prime dt separately from the part that has the y prime dt. But ultimately, they all get tossed into the same sort of alphabet soup to evaluate the final integral. So let's first parameterize this curve. The top half of the circle, x squared plus y squared equals 1, from 1, 0 to negative 1, 0. That means we're looking at this as C1. That's the first portion of the curve. And the second portion is the line segment from negative 1, 0 to negative 2, 3. So negative 1, negative 2, negative 1, 2, 3. So then as the second portion, we're going along here. Okay, so C1 is going to be x equals cosine t and y equals sine t for t between 0 and pi, because those are the places where we're headed. We're headed from the right-hand pole of the unit circle to the left-hand pole of the unit circle. That's from the 0 position to the pi position, okay? And we're going to have some more stuff to do on C2 eventually, but we'll just do that when we get to it. So what does this mean? This means that dx dt is going to be negative sine t, and dx is going to be negative sine t dt. Similarly, dy dt is cosine t, making dy equal to cosine t dt. So along C1, we're going to have integral of sine of x. So think about what this means. Sine of x, that's sine of cosine of t, right? So it's going to be integral of sine of cosine of t, and then dx is times negative sine t dt, and then plus cosine of y, that's cosine of sine of t, multiplied by dy, which is cosine t dt. And the integral will be from 0 up to pi. So I don't think I'm going to have room to evaluate that, so I'll move it. There we go. Now, this seems kind of lousy, right? Because you've got a trig function of a trig function, sine of cosine. But watch, if you pay attention, you actually see some very nice stuff happen with the du's. So in this case, if you take u equal to cosine of t, then du is equal to negative sine t dt. And look at where that happens. It's right here. So this very quickly turns into sine of u. And the integral of sine of u is negative cosine of u. So this will turn into negative cosine of cosine of t. And for the same reason, but in reverse, this is going to be, if you set u equal to sine of t, then du is going to be equal to cosine t dt, and that shows up right there. So this will contribute a sine of, sine of t, and these are going to be evaluated at 0 and pi. So for the pi evaluation, cosine of pi is negative 1. So we've got negative cosine of negative 1 right there. Negative cosine of negative 1. And then sine of pi is 0. Sine of 0 is 0. So this is plus 0, which you can choose not to write if you want. And then minus the 0 evaluation, cosine of 0 is 1, and negative cosine of 1, we'll simply write negative cosine of 1. Then sine of 0 is 0, and sine of 0 again is 0. So this will be plus 0, which of course you can simply choose not to write. And let's see. Cosine of negative 1. Cosine is an even function. So by evenness, negative cosine of negative 1 is the same as, you can take the minus sign and just remove it. I shouldn't have drawn an arrow there. Negative cosine of negative 1 is the same thing as negative cosine of positive 1. You should stop and think for a second. If you don't understand why that's true, it's because cosine is an even function. And so negative inputs get the same outputs as positive inputs. This is going to be useful because now it's going to be a like term with this, where it wasn't before. So this is going to be negative cosine of 1 minus a negative of cosine of 1. That means plus cosine of 1, or 0. So the integral of this along the first curve is actually just 0. So then along C2, well, now we have to parameterize this. This goes from negative 1, 0 to negative 2, negative 3. From negative 1, 0 to negative 2, negative 3. We can parameterize this. X is going to be equal to the starting point, negative 1, minus 1t, because that's how you get from negative 1 to negative 2 as t goes from 0 to 1. Y is going to be the starting point of 0 minus 3t. So simply negative 3t. Then dx is negative dt, and dy is negative 3 dt. So hopefully this will be a little bit easier. We've got the, sorry, I'm getting over a cold. Put your mask on while you're watching this video. So we've got sine of x and cosine of y. I'll just copy it down here. Sine of x dx plus cosine of y dy. And this is along C2 now. So this is going to be equal to integral from 0 to 1, because those are the values for the parameter here. That's how we chose the endpoints. 0 to 1 of sine of x. That'll be sine of negative 1 minus t, dx. dx is negative dt. So this is times negative dt, and then plus cosine of y, which is cosine of negative 3t. Well, remember, we just used the evenness of cosine before, so I'm going to use it again. This is really cosine of 3t, right, by evenness. And then times dy, so times negative 3 dt. So collecting all this together, I'll have integral from 0 to 1 of sine of negative, let me write the variable first, negative t minus 1 plus cosine of 3t, except really that's minus 3. So I should be writing it that way, minus 3 cosine of 3t dt. Integral of sine is negative cosine. So this will be negative cosine of negative t minus 1. But the minus sign on the inside here means that we would have multiplied by negative 1 in the derivative according to the chain rule. So that means that this minus sign is bye-bye. Okay, so now the derivative of this would be negative sign because of cosine, but then its sign would get reversed again because of the chain rule from the negative t on the inside. I know it's difficult to keep track of all the moving pieces. And then the integral of cosine is simply sine, because the derivative of sine is cosine. So this will be minus 3 times sine of 3t. And then if you take a derivative of this, you would end up multiplying by 3. So to take care of that, we divide by 3, which simply cancels with that. And so you can just not write those parts. And the derivative of sine of 3t, of course, is 3 cosine of 3t. This is going to be evaluated at t equals 0 and 1. Okay, let's put in the 1 first. Cosine of negative 1 minus 1 is cosine of negative 2. But you and I both know that that's the same as cosine of 2. So cosine of 2, and then minus sine of 3. Minus, and this will be the 0 evaluation, cosine of 0 minus 1, which is cosine of negative 1 or cosine of 1. And then minus sine of 0 is 0. So collecting, this is cosine of 2 minus cosine of 1, just so that we're writing the cosines together, minus sine of 3. And there you have it. These are not degrees, they are radians. And so you do just have to leave them like this because nobody knows what those are going to be equal to. But this is it in exact form.